Welcome to the third chapter about our linear algebra course. So this is going to be called linear maps. Okay, so this chapter is going to be divided into 6 parts. Okay, we will start the chapter with isomorphism. Okay, and we will see the first part. We will have in the first section. We'll see some definitions and examples. Then in the second section, we will see some very important lemmas and theorems about isomorphism. Especially, we will see that the dimension characterizes isomorphism. Isomorphism. Okay, so in the second part, we will see homomorphism. Homomorphism. Okay, and here as well, in the first section of this part, we will see some definitions. And the examples. And in the second section, we will see the range space and the null space. The range space and the null space. I will define all these concepts in the next few videos, okay? In the null space. Here is just to give you an idea about what the chapter is going to be about, okay? So in the third part, we will see how do we compute linear maps, okay? So computing linear maps. So how do we go from a transformation or a map to a matrix? Linear maps. And here in the first section, we will see how do we represent linear maps with matrices. So representing linear maps with matrices. In the second section, we will see that any matrix represents a linear map. Here we will try to find some facts about the linear map through its matrix, okay? So if you are given a matrix, we can get some facts about the underlying linear map. So here we will say any matrix represents a linear map. Then we will move on to section 4. Let me write it here. Part 4, sorry, for the chapter. We will see matrix operations. So this is going to be a very long chapter. It is the longest chapter in our linear algebra module, in this linear algebra module. So part 4 is matrix operations. And here we have several sections. The first section is about sums. and the scalar product. So how do we add two matrices together, and how do we multiply a matrix by a scalar? So sums and scalar product. In the second section, we will see how do we multiply two matrices together. So matrix multiplication. Part C, we will see some mechanics of matrix multiplication. And we will end this fourth part with inverses. How do we find an inverse of a matrix? Okay, so then we'll move on to part 5. Okay, here is change of basis. So if we are given a transformation, basically we are given a transformation and a set of bases. We will be trying to see how do we represent that same transformation in a new pair of bases. Okay. Or even if we want to change a matrix, or a matrix from a basis to another basis, what is that matrix that we can use or allows us to change that matrix, okay, in the first pair of bases to begin with. So bear with me, and I will go into depth of those concepts shortly. The first section is going to be changing representation of vectors. Changing representation of vectors. B, we have changing map representation. Changing, that's what I have explained just a while ago. Changing map representation. And we will finish this chapter with the 6th part, where we will talk about projection. Here we will see in the first section orthogonal projection into a line. Into a line. And finally, we will see the Gram-Schmidt orthogonalization. Okay. Gram-Schmidt orthogonalization. Okay, so these are all the concepts we will discuss in this chapter. So see you in the next video with the first part, where we will talk about isomorphism. Thanks.